We are beginning DMA 40 sections 1 and 2. The first thing that we're going to be introducing in DMA 40 is we are going to be working with variables. Up to this point, we have worked with numerals and we have done computations with various numerals, positive numbers, negative numbers, integers. So what we are looking at now is variables. A variable could be an X, a Y, a Z, the letter M, N. Any number can be used to substitute in the place of the variables. So as we work with, we're going to look at two different things. We're going to look at what's called an algebraic expression, and we're going to look at an algebraic equation. And let me show you the difference between the two. An algebraic expression could be simply 2x plus 3. So this would be an expression. We may be asked to simplify an expression where we plug in a value for x and solve. If we have an algebraic equation, we might have something such as 5x plus 1 equals 11. An equation has an equal sign, and when you have an equal sign, that means we're going to solve and ultimately get an answer of x equals, and then we would have a numeral on this side. When we evaluate an expression, we are going to substitute a numeral in place of the variable. So if I were to have, let's say, 2 times x minus y, and let's say we are told that x is going to be a 7 and y is going to be a -4. That means where the x is, we plug in the number 7, then we have a minus sign, and our y is a -4. And notice I'm going to put another parenthesis around that -4. What we have here from what we learned in DMA 10 is when we are subtracting a negative, that becomes plus a positive. And 7 plus 4 would become 11. And 2 times 11 gives us a solution of 22. Let's do another example. Let's take 4x squared minus 2z. Now notice when I write the letter z, I put a little line through it so that I don't confuse my letter 2 with the variable z. Let me also add up here that z, we're going to substitute and use the number 2 in place of the z. So if I am evaluating this expression, I'm going to have 4 times 7 squared minus 2, and the z is going to be replaced with a 2 also. So 7 squared is 49, and then if we do 4 times 49, that gives us 196. And I don't know where that 2 just disappeared to. It just like jumped away. Okay, so now we have minus, and 2 times 2 is going to be 4, and 196 minus 4 gives us 192. And that would be our solution after we have simplified this particular expression. You will also be working with translating equations into an algebraic expression. When we are working with something such as this, and what I would ask you to do is to look in your Leap Log workbook, look in workbook, and on page 4-7, you're going to see your list of terms, list of key terms. And these key terms you'll use as you are working with writing an algebraic expression. For example, if you're adding, a key word that you might see is the word sum. If you are subtracting, you might see the keyword difference. If you are multiplying, you would see a keyword product. If you were dividing, you would see a keyword of quotient. If you're looking for equals, you might see the word is. Now, there are plenty other words that you may see. Under addition, you might see something such as total, plus, increase. So you would look for keywords. For difference, for a subtraction, you might see the word minus, you might see less than. For multiplication, a keyword for multiplication would be the word, and you wouldn't have thought of this normally, is the word of. You might see times. You might see words such as twice, double, triple. All of these would let you know that you are multiplying. Quotient, you could see words such as half, divided by. You might see the word per or ratio. For equals, we have is. We might see the word yields. We may see the word gives, or we might see results in. So these are some keywords that you would see as you're trying to determine how to write these. So let's look at a couple of examples. If I were to ask you to show me twice a number. Twice a number means, and we're going to use the variable x, that means we're going to have 2x. When you have a number and a letter side by side, that means they are being multiplied. If you were to see 6 less than a number, what I want you to do is 6, when it says 6 less than, does that mean 6 minus, or does that mean that 6 is less than a number? What you may want to do is to write it both ways and then go back and read it again carefully and see which makes sense. 6 less than a number. When I look at this, this says 6 minus x. So this is saying the number is less than 6. So that is not going to be the correct option. Here, 6 is less than the number. The number is subtracting 6 from it. So that would be the correct choice. Okay, let's look at 10 added to 3 times a number. 10 added to 3 times a number. So we would have 10 being added to 3 times the number, which would be 3x. This technically would be acceptable, but the usual order we put things in is we're going to learn that we use our variable terms with variables first. If they have exponents, we use descending order, and then the single number would be left at the end. So you will also in section 1 be looking at taking an expression and writing it as an algebraic expression using variables. As we continue, we're going to be looking at some properties of numbers. The commutative property. This property applies to addition and multiplication. With the commutative property, that means The way that you add the numbers, you can change the order. You may change the order of the numbers, and it's okay. You're going to get the same value. If I'm multiplying A times B, that's the same as B times A. Let me give you an example. 1 plus 3 is the same as 3 plus 1. Both of these give me a solution of 4. If I had 5 times 7, or if I had 7 times 5, each of these would give me a solution of 35. So with the commutative property with addition and multiplication, you can change the order of those numbers. The associative property, and again, this applies to addition and multiplication. The associative property has relationship to grouping. So you may use grouping in any order. So if I have a series of A plus B plus C, I could group the first two, or I could group the last two. So if I had 1 plus 2 plus 3, and still 1 plus 2 plus 3, 1 plus 2 is 3. 3 plus 3 gives me 6. Here, 1 plus 5, 2 and 3 gives me the 5, and 1 plus 5 is 6. So you can group any of the values, and the same thing applies to multiplication. A times B times C would be the same as if you had A times and you grouped the B and the C. You're going to get those same values. Let's now move on to the identity properties. Identity property. Now, the first one that I'm going to ask you about is going to be addition. If I have 7 plus a number and I want it to still give me an answer of 7, what would I add to 7 in order to get that same answer? I would add a 0. So if I have x plus 0, it's still going to give me the answer of x. If I look at this same property for multiplication, if I had, let's say, 8 times a number, and I wanted my answer to be 8, what would I multiply by? I would multiply by a 1. So x times a 1 is still going to give me that same value of x. Another concept we're looking at is the term additive inverse. An additive inverse adds up to 0. So, for example, if I give you 4 plus, and I need a number here, what would I add to a positive 4 to get 0? I would add to it a negative 4. If I had started with negative 9, and I'm going to add a number to it, what would I add to a negative 9 to get a 0? Positive 9. So the additive inverse makes it add up to 0. So in essence, if it's positive, you give the negative. If they give you the negative, you would use the positive. A multiplicative inverse multiply to give 1 as the solution. So if I were to have 3 and I need to multiply it by a number to give me an answer of 1, what I would do is technically 3 is like 3 over 1. So if I wrote the reciprocal of 3 over 1, that would be 1/3. 3 times 1 is 3. 1 times 3 is 3. And when I simple 3/3, that gives me 1. So a multiplicative inverse, in other words, is going to be the reciprocal of a number. Let me give you another example. Let's say we have 5/7 and I need to multiply by it to get a 1. What is the reciprocal or the multiplicative inverse? I would flip it upside down. 5 times 7 would give me 35. 7 times 5 gives me 35. And this fraction, 35 over 35, simplifies to be 1. So a multiplicative inverse is when you're writing the reciprocal of the number. And the last concept that we're going to look at here is going to be, and this is one of my favorites, we're going to work with the distributive property. The distributive property you're going to continue to work with throughout your math career. With the distributive property, we're going to have a value that sits outside of a parentheses. Inside of the parenthesis, you may have something that's going to be added or subtracted. When we use the distributive property, we're going to take the first term outside and multiply it by the first in the parentheses. So that would be AB. Then I'm going to take the A and multiply it by the other value, which is a positive C. So that would give me AC. So let me give you an example. Let's say we have 6 times x plus 4. So when I multiply, I'm going to do 6 times x, which gives me 6x, and then 6 times 4 is going to give me a positive 24. If I were to have, let's say, negative 8 times x plus 2, I would distribute. Negative 8 times positive 1x would give me a negative 8x. Negative 8 times positive 2 would give me a minus 16. Let's do one last one. Let's do negative 8. No, let me change the 8. Let me use a different number. Let's do negative 5. And then let's say we do 2x minus 9. So negative 5 times 2x would give me a negative 10x, and a negative 5 times a negative 9, negative times negative gives us a positive 45. So when you're using the distributive property, you're going to multiply what's in front by the terms inside. So when you multiply, what I want you to keep in mind in this order is that first you're going to identify what is the sign. Then you're going to write down the number when you multiply the numbers. And then is there a variable? If there is a variable, you have to include it. So you're going to multiply and you ask yourself, sign, number, is there a letter? And then at that point, you're done. Thank you.